Hey guys, welcome back everybody. 1 minute. Change. All good, right? Hey guys, so in the last classes, what we have done. So let me recap yesterday what we have covered. So basically, yesterday we have seen the purpose of networking, right? What is the major purpose of networking? So we have seen that the major purpose of the networking is what? To exchange the data or we can call as a information. Your information could be anything. Either you're sending the video traffic, right? Either you're sending the MP3 traffic, right? Music, you're sending it. Either you're sending a text traffic, anything. Even if you're calling someone, that's called as a networking. Because in the calling, what happened? You're normally exchanging your data, either making a voice call or either making a video call. Right now, whatever the Zoom calls we are doing right now, this is also called as a networking. Then after that, we have seen that types of traffic, right? So in the types of traffic, we have seen that we have three types of traffic basically. One is called as a unicast. That's called as a one-to-one. Then after that, we have seen that broadcast. And normally in the broadcast, what happened? We have a one-to call, right? And then we have a multicast. In multicast, we have a one-to group. So if I take example of this one, like a unicast, broadcast, and a multicast. So take example. Uh, Let me draw it. So I just need a 5 minutes to recap the study so that we will be on the same page, everyone. So this is the PC1, PC2, PC3, PC4, right? And these PCs are connected via the any of the one medium. Take example. So this is the one of the device, and we have a connectivity like this way, like this, and like this. So we have a PC number one, PC number two, PC number three, and PC number. So take example, if the PC1 is sending the data to the PC2, right? So if the PC1 is sending the data to the PC2, that's called as a unicast communication. That's called as a unicast communication. If the PC1 is going to send the data to the everybody, for example, to the PC2, PC3, and PC4, this kind of communication is known as a broadcast because now the PC1 is sending the data to the everybody. The third type of communication is known as a multicast. Now, in this case, what happened? Logically, what the PC1 will do, it will create a one group, right? So in this case, what happened? Now the PC1 is only going to send the data to the PC3 and PC4. This kind of communication is known as a multicasting. Right now, the Zoom call we are doing, this is called as a multicasting. You are watching the YouTube, multicasting. Creating a WhatsApp group, multicasting, right? Then after that, we have seen that to identify the device, we need to define one identity, and that identity is called as a IP address. So every person has a identity, right? For example, my name is Law, and I'm living in the Raisandra. So Law is a name, okay, and living in the Raisandra. These are two different things, right? But in the networking world, what happened? We have a single thing that is the IP, and that single thing is going to represent that two things. One, the IP itself represent that it's a location, right? And second, it will represent that identity. So basically, your IP represent two things. So for example, there is an IP address 1.1.1.1.1, right? Take example, a roughly example. So this IP is going to tell, okay, this PC is located in the Bangalore, okay, and this PC is belong to the Law. Normally, a person, right? Take example, the person. So take example, there's a RAM, right? So for example, in the RAM, what happened? So RAM is a identity, right? But this guy is living in the Delhi. So there is a two things over there. One, we have identity, and another is a location we have. But in the case of IP, what happened? The IP itself represents the location. At the same time, IP itself represents the identity 2. So we have also seen that the IP has a different classes, right? So we have seen the class A, right? In the class A, we have seen that we have a range of the classes start with the 0 to 126, right? Right? Or what was the 126 or 128? What was the range of the class A?
126.
Okay. How about the class B?
Because class B.
128 to 1.
Okay, so 126 was there, 127 is reserved for the loop back. And I
Loop back.
told you that we are going to discuss this loop back in the next class, okay? So the class B, it's going to represent the 128 to the 191. The class C, we have, its range is 192 to the
223.
and then we have a class D. Sorry. The class D, we have a 224 to the 239. And then we have a class E. We have this guy's a 240 to the 255. So these are the range of the classes we have, right? Class A, class B, class C. If I talk about the purpose of these classes, right? So if I talk about the purpose of this classes, this class A is totally dedicated for the unicast and broadcast traffic, right? Then if I talk about the class B also used for the same purpose, a unicast and broadcast. Then we have a class C. The class C also have the same purpose, unicast and broadcast. If I talk about the class D is only present for the multicast, right? And class E, which is reserved. So, let me tell you one thing about this guy. So if you're gonna read some older books, like maybe, before the 2015 and 17, right? So you will find the class E is reserved for the documentation purpose, okay? If you're gonna read the new books, right? In the new books, what you will find, this guy is reserved for the future purpose, right? So don't confuse with the terminology, right? So even if you see the in interview, if somebody will ask you, hey, what is the use of class E? You can simply say that, okay, that class E is used for the documentation purpose, and you can also see that the future purpose, both are correct answer, right? So I'll just mention the documentation, right? And future purpose. So these are the classes we have. Then after that, what we have done, let me make a pointed out there so that, the main purpose of the networking. Then we have seen the types of traffic, right? Then we have seen the IP is used for the two things. One is for the location and second is the identity. Then we have seen that whatever the classes we have. After that, also we have covered the basic part about the MAC addresses, right? So MAC addresses I told you that, it's a 48-bit address. Let me write down one more thing. IP addresses, right, is a 32-bit address, right? And IP addresses we define IP addresses, IPv4 addresses, that will be correct sentence. We define IPv4 addresses in dotted decimal format. Okay, then after that, we have seen the MAC address part. So in MAC address, we have discussed about the MAC address is a layer 2 address, right? Which is a 48-bit address. The representation of the MAC address in hex format, and whereas the IPv4 address is in the decimal format. And after that, the MAC address is also known as, okay, so guys, if the spelling is mistake, just ignore the spelling. Also known as a data link layer address, right? Many people has defined a different name. Okay, also known as the Ethernet address. The reason we call as a Ethernet address because it is only present on the Ethernet technology. Let me tell you about it. So normally we have our cables in networking, right? So either you have a cable, right? If you are like, in the older school, right? If you guys are like, have about more than 10 to 15 years of experience in the networking, then you have might seen that serial link, right? But nowadays, right, people are using the Ethernet technology. People are using the Ethernet technology. Guys, so right now, what happened? We have right now we have a Ethernet technology. In a Ethernet technology, what happened? You will say the 10 meg, right? 100 meg. You will say the 1 gig, 10 gig, right? They will use the 100 gig as well as up to the 400 gig. You will see that speed. That's a Ethernet. So either you will see the 10 gig fast Ethernet, 10 gig fast Ethernet, right? Or either you will see the gig Ethernet. Either you will see the Ethernet, right? Whatever the cables you will see in this family, fast Ethernet, Ethernet, and gig Ethernet, all these cables, right? All this cable have a, right, on that particular port, you have a MAC addresses. So when this cable is gonna put on the particular port, on that particular port, we have a MAC address. But if I talk about the serial link doesn't have a MAC addresses. And because of this reason, the MAC address is also known as a Ethernet address, because that MAC address is present on the Ethernet card. Then it is also called as a burn-in address. Why we call this as a BIA, burn-in address? The reason is that, when the MAC address, right, when the NIC card is being manufactured, right, on that time, what happened? The engineers, right? So take example, this is the NIC card, network interface card. On the NIC card, what happened? Your MAC address is present. So during the manufacturing the NIC card, the engineers are putting the MAC addresses right over here, like this way. So on the time of manufacturing, they put this MAC address on the hardware. Because of this reason, right? Because of this reason, it's known as a burn-in. Burn-in is what? We have to paste this information on the hardware. And after that, we cannot remove it. And because of also this reason, right? Because of burn-in address, it's also known as a physical address. So people has defined the different name of this address. You may find the other name as well, right? Simply, if you see the 48-bit address, it's known as the MAC addresses, right? Then after that, we have covered the basic part about the, whatever the devices we have. So we have discussed the devices like a host, right? Host we can call as a PC, computer, right? Then after that, we have seen the devices called as a hub. Then we have seen the devices called as a server hub. Then we have seen the switch. Then we have seen the router as well, right? Then I have discussed about the firewall, right? And then I have discussed about the WLC and those, right? AP access point, right? But let me tell you, I'm not gonna make a deep dive on this particular products because we don't have these products in the enterprise. Basic part is there, बहुत ज़्यादा basic, okay, but it's not there in the detail. So we have to focus on this part. Now, let me tell you something about this component, and then we'll again back to the jump on the IP addresses part. Now, so normally everyone knows what is the meaning of PC and what is the meaning of computer and what is the meaning of laptop, right? So right now I'm taking your class on my laptop. You have a laptop. So with the help of laptop, what you can do that with the help of laptop, right? Either you can watch the movie, depend on the person to person, right? They have a different work. Guys, please pay attention. We are moving towards the practical part now. So based on the requirement, people can do the different job. For example, I'm a network engineer. I can do the networking stuff. If some guys are the graphics engineer, they can do the graphics, right? So they can install the graphics tool in their laptop and they can do some their stuff, right? If their guy is a software engineer, they can do the coding part. If some guys are a hacker, they can do the hacking part through the laptop. So one person can do the different job through this laptop. So laptop is called as an end host as well. Why we are calling this end host? Because it is represent a particular person, right? At the same time, before the laptop, we had something called as a computer. Computer is a pure like hardware device, you cannot carry the computer, but you can carry the laptop. That's a major difference. In a computer, what happened? You have a multiple, like, you have an individual CPU, right? Okay. Then we have a individual keyboards, individual mouse you have, then monitor you have. But in the case of laptop, what happened? Everything is assembled in the single box. That's a major difference. You can carry the laptop, but you cannot carry the computer, right? Second thing is that server. What is server? Server, as I told you, is study, right? So normally your laptops are maybe the 8 gig RAM, the 4 gig RAM, right? Either you can go with a 16 gig RAM. Even like, my laptop is a 16 gig RAM. My friend laptop is a 32 gig RAM. Even I have seen that one of my friend has a 64 gig RAM as well, right? Even the laptops are coming in the 128 gig RAM as well, right? But I haven't seen that the 256 gig RAM or maybe the 500, well, something gig RAM. So if you have a requirement of the big RAM, maybe the 5112 or maybe the 1024 something amount of RAM, then you cannot put those things on the single laptop or not in the computer. Then you need to take a powerful laptop, and that powerful laptop is known as a server, because those things, right, are comes in the 5112 GB RAM or maybe 120 GB RAM, maybe it's coming the 256 GB RAM, right, with the multiple core CPU, right? So that's coming in the server. As the name suggests, yesterday also I told you the same thing, right? Everything, try to correlate each and every words with the real life. Server, the meaning itself saying the serve means what? Whenever the client, so normally what happened? These clients doesn't have a, right, this end host doesn't have a much processor. So what he will do that? So normally they will take a request from the server. So meaning of server means what? So whenever the client will request to me, I will serve that particular request. That's the meaning of server. Now the next part we have the next device we have call as a hub. Now, normally this device, right, it was there in the 90s, 80s time. Okay, so when the networking was born, right, in the during the 90s, 80s time. Okay, so let me tell you one more thing about the networking, right? So most of the people are thinking, okay, Cisco gave the networking. Okay, I'm not denying it. But before the Cisco, right, and before the Juniper, right, networking was already there in the market. Cisco is a vendor that giving the products to us, the networking products. If you just Google on the, like, if you just go in the Wikipedia, right, Cisco was introduced in 1984 or 1985 something, right? And but networking was there before 1960 time, because ARPANET came in the 1959 and 1960 during that time. Okay, so don't think like, Cisco gave the complete networking. Okay, Cisco just giving the products of networking, right? So that with the help of that products, we can deliver the networking. Now, so hub was that, hub, this is the product in the very older days, and then during the 1970s and 1980s. Now, the reason behind the hub is what? Take example. I want to exchange some data between. So take example, this is the PC number 1, and this is the PC number 2. So normally, right, this PC, right, sort of be on mute. So normally the PC1 and PC2, right, they can exchange the data. Guys, please pay attention. They can exchange the data. So right now, take example, I have a cable, right? And through this cable, right, is a media. In a layman language, if I tell you what is media, media is something that they can carry your information. For example, you are sitting at right now HSR layout, right? And you want to go to the Koramangala. That's your destination, right? You're living in the HSR layout and you want to go to the Koramangala, but you don't have any vehicles, right? What you will do that? You will take a bus, right? You will take a bus. So normally you will sit in the bus and then you will reach to the Koramangala. So this bus is going to represent as a media. So same thing, right? When the PC1 is going to communicate with the PC2, right? When the PC1 want to communicate with the PC2, we need a help of media, right? We need to take a help of media. We cannot share the data in a air, right? We need to take a physical cable. right? And that physical cable is known as a media. So once I'm going to connect this guy between the PC1 to the PC2, now I can send the data, right? Whatever data I have, I can send it. That's good. That's amazing in the 90s, 80s time. But what happened, right? During the 90s, 80s time, the requirement comes in the picture. So, okay, now I have a more user. So take example, I have another user over there, the PC3. And he also wants to exchange some data. So what you have to do that, you need to take another cable, right? And you need to take another cable and put the cable down. And now you can exchange the data over here now, right? This is how we can extend the data. That's amazing. But again, what happened? Requirement comes in the picture. So, hey, now we have another guy, and this guy also wants to extend something. Now we have to put the cable like this way and this way. And now this way, because the PC4 also wants to communicate with the PC3. Understood? So now we have to extend the data between the all this guy. Now you tell me, is it a possible, right? We can put the multiple cables on the single PC. You know, you can put the 3 cables, 4 cables, 5 cables. Like you can take an external adapter as well. Normally in your computer, if you see just right now, if you're watching the taking class from the laptop, you can see in your laptop, okay, there is a RJ45 cables, right? Adapter is there. The ports are there. How many cables you get? If you don't have RJ45, even if you have a USB, then you can take a connector of the RJ45 and then you can connect it. But how many? 3, 4, 5, 6, 10, right? But you cannot put the 100. For example, if you have a 100 PC and you need to provide the networking between the 100 PC, you know, to exchange the data between the 100 PC, is it possible that I can use the connectors over there? No, it's not possible. So during that time, right, the new person came in the picture that called as a hub, right? So hub said, hey, don't worry about that. You don't need to provide the cabling between the PC to PC. What I can do that, I will provide you the connectivity. How? Let me tell you. So hub is a plug and play device. Plug and play. It's same like your extension board. Do you guys see the extension board? Let me show you that. Yeah, this thing. So normally what happens, this extension board, when you put this cable into the power board, right? So you will get the connectivity, you will get the electricity in this board, right? And then finally you can put your laptops, you can put your charger's phone, you can put the anything over there. Finally, you will get the electricity in this board now, right? Same thing is happening with the hub. What hub is gonna do that? Hub is just like a plug and play device. So what hub is saying that, hey, don't worry about that. You just put the cable with me, just put the cable with me, just put the cable with me, and just put the cable with me, and I will provide you the connectivity. That's a beauty of hub. The hub saying that, hey, don't worry about that. Just put the cable and I'll give you the connectivity. That's hub comes in the picture. But the problem with the hub is what? Let me remove this guy. Right? The problem with the hub is what? This guy, this hub, right, is a very dumb person. Is a dumb means what? If you say something to a dumb person, try to understand, he cannot understand anything, right? So if you're sending any packet, for example, if the PC1 wants to communicate with the PC2, right? Doesn't matter if the PC1 is sending the unicast packet or broadcast packet, and even the multicast packet, right? The hub cannot understand it. So take example, there's a one packet where we have a source is a PC1, right? And the destination is a PC2. Can you see that it's a pure unicast packet, right? Because I have mentioned the source is a PC1, destination is a PC2. Normally, you know what happened in this case? When the packet comes arrive on this particular interface, right? What he will do that, it will regenerate the signal, right? When the hub will receive this signal, it will regenerate the signal and send it to every person. Can you see that what's happening over there? The packet is only for the PC2. The destination is PC2, but the hub is sending the packet to the every person. That's a biggest issue with the hub. But again, on the 90s, 80s time, it was amazing. Because on that time, right, we only had a requirement of what? I need a communication. I need to avoid the cabling. I need to avoid the cable because in that previous case, what happened? I have a multiple PCs over there. I have to cable like this way, right? There's a multiple cables over there. Cost comes in the picture, right? And how many cables I can put it over there? So on that time, we just need to remove these issues, right? And that's why we came with the picture of the hub. Hub was amazing, but days by days, right? When the things become bigger and bigger, right? Then what happened? We found an issue with the hub is what? Hub does not understand any kind of packet. And there's a reason behind it. The reason was what? This hub does not able to identify, right? Guys, make a note of this thing. Not able to identify MAC, not even the IP. They don't have any buffer. Buffer in the sense they don't have any memory. They cannot identify it anything. So normally what happened in that case? He will do the broadcasting. Anything you are sending, either sending the multicasting, either sending the broadcasting, either sending unicasting. He cannot understand these packets. This is the biggest issue with the hub. I'll show you the practical, don't worry about that. Okay, then after that, what happened in 90s time, right? In 90s time, the new person arrived, right? That's called as a switch. But let me tell you one thing. After the hub, right, there's another device is named as a bridge. So I'm not going to talk about the bridge right now, okay? But I'll just tell you, let you know, bridge is the advanced version of the hub. The bridge can understand the unicast packet, can understand the multicast packet, can understand the broadcast. But the problem with the bridge is what? You can use the bridge for the small network. You cannot use for the bridge for the big network. And that's why the bridge has a scalability issue, and we resolve this issue with the switch. So in the 90s time, they came with the concept is called the switch. So now the hub is going to replace with the switch. And finally, the beauty of the switch is what? The switch can understand everything. Switch does have an ability to understand the unicast packet, does have ability to understand the broadcast packet, does have ability to understand the multicast packet. Able to identify the MAC. So if I'm sending, if PC1 wants to send any traffic to the PC2, where we have a source is the PC1 and destination PC2, the packet only go to the PC2. It will never go to the PC4, not in the PC3. And that's the beauty we have in the switch. But again, switch has own limitation. The limitation of the switch is what? You can have a switch, you can make a networking, right? You can make a networking with the help of switch within the one building. Within the one building, you can make it, or within the one society, you can make it. But if you want to send the data from one country to the another country, for example, let me tell you. So take example, this is a switch we have, right? And we have our PCs over there, they are connected. And then we have some servers, right? And we have another switch over here, switch 2, right? And we have some PCs. Guys, just I'm giving the very brief information of this thing so that you will become the familiar with the words. We have a detailed discussion about each and every devices. Don't worry about that. So now what happened? Take example, we have this device in the Delhi location, right? And this device in the Kabul, okay, a different country. In that case, do you know what happened? Right now the PC1, right, in the Delhi can communicate with the PC2, even the server one. So PC1 can communicate with the PC2. Even the PC1 can communicate with the servers. Over here as well, the PC1 can communicate with the server, right? And PC2 can communicate with the server. But normally, this communication is not going to happen. If I want to communicate between this server to this PC, not possible. So in that case, what we have to do that, because these guys are in the different location, maybe in the different network. I know you might don't know about the network right now. That's why I haven't used the words network. But if you know, that's good. If you don't know, then leave it. Just ignore this word right now. Because this guy's in the different network and this guy's in the different network, right? In that case, we need to bring a new device that's called the router. So we need to take a help of a router, right? Or like this way, right? Like this way and like this way. And then I can provide the communication between the Delhi to the Kabul. So each devices has a own role. If you see, right, you can use this devices into the LAN networking, right? You can use this in the LAN networking. Then if you want to use the WAN networking, then you have a router over there. Without router, you cannot provide the WAN communication. You have to have a router in your network, then you can provide the WAN communication. Without the router, you cannot have. So these are the basic information about the devices. Hope this thing is clear to all of you guys. Do you have any questions till this point? Or we'll see the practical as well.
Hello,
Yeah, go ahead.
the Saurav this side, sir.
Yes, sir.
My question is, in a small organization, sorry, sir, for LAN communication,
Mhm.
is there we need a router or switch, sir? Yeah, directly we can configure switch
See,
for LAN network.
I'll tell you. I'll tell you. So in the LAN network, as I mentioned, that you can go with the switch, right? You cannot go with the router. But there's a requirement comes in the picture that I'll come to the next part. Okay, when I'm gonna talk about the VLANs, right? Then I'll show you that you need a router over there. So take example. Let me explain you this part if you know. So if somebody don't know about this one, just ignore it. So take example if this PC and this PCs and this PCs and this PC, right? In the different VLANs, VLAN 10 and VLAN 20. Take example. Okay. And you want to provide the communication with between these two VLANs, then you need your router over there in the own network as well.
Means, sir, I can configure inter VLAN, sir.
Yeah, you can configure the inter-VLAN. Yeah.
Okay, sir.
Don't worry, we'll discuss this thing as well. Okay. Now, let's talk about the basic IP part. Now, let me do one thing. Hold on. I need to just grind it down. And come on. And over here, this passage down. Now, this part are very important now. IP address is a 32-bit address. We define the IPv4 address in a dotted decimal format, right? The size of IPv4 address is a 32-bit, right? This IPv4 address is also known as a logical address. What do you mean by logical addresses? As I just mentioned that your MAC addresses, right? Your MAC is represented as a physical address. Your IP is going to represent as a logical address. The reason is behind it. Okay, this is a very interview question, very important interview questions, right? The MAC addresses are present on the hardware. On your NIC card, network interface card. IP addresses not present on hardware. If it is not present on the hardware, it is known as a logical address. It means that physically you can see the MAC addresses. Physically, you can see the, let me show you this thing. Just put the information. So can you see that? These are the NIC cards. We have a MAC addresses over there. This is MAC ID. But you cannot see, this is the hardware, right? It's a hardware component that's present on your PC, right? It's there over there, right? But you cannot see the IP addresses written like this on the hardware. Not see that. So maybe you have a question. Hey, Law, you know one thing? I do define the IP addresses on the interfaces. Okay, so when you define the IP addresses, let me tell you, when you define the, come on, when you define the interface 0/0 and you see the IP addresses, right? This command 1.1.1.1.1 and /8, take example. In that case, you are defining the IP address on that particular port, right? But that is not physically written on that port. It's a virtual. You're putting the command. You're not writing it, but the MAC address is written on the hardware. And normally when you put this command, you're giving the instruction to the hardware box. Hey, you know, one thing, I like to define the IP address on that particular interface. That's a command line. So there's a difference is that. So that's why IP comes in the logical, right? And MAC address comes in the physical. IP addresses can be changed. MAC address, you cannot change it. Because it's there on the NIC card, you have to completely change the NIC card. But on the Cisco devices, I'll show you, just remind me, okay, if I forget, I can show you to how to change the MAC address as well as via the command line. Okay, now, the range of the IP addresses, I say that the range of IP addresses is 0 to 255. So you will see the range from here. So you can see that as well. So start with the 0, right? And with the 255, right? Each classes, right? This IP addresses, each classes has a different perspective. You can see that class A, class B, and class C is only for the unicast and broadcast, and class D is for the multicast, and the docs in future was class E. Your IP addresses, right? As yesterday also mentioned that this part is a 32-bit number. This 32-bit number represents the decimal format, and it has a, right, 4 portion, 1 portion, 2nd portion, 3rd portion, and 4th portion. Each portion, right, is going to represent that 8 byte, or we can say the 1 octet, sorry, 8 bit. We can call as a 1 octet. 2nd octet, 8 bit. 3rd octet, 8 bit, and the 4th octet, 8 bit. And now in this one, I can put the IP address. For example, if I say, take example, if I say 1, 1, 1, 1, dot, 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 because it's a dotted decimal. So if I say the 1.1.1.1.1, it means that what? This guy is a part of the class A. So your first octet, right, guys, please pay attention. Your first octet will tell you which class this IP belongs to. Your first octet define you which class this IP belongs to. Based on the first octet, right? Based on the first octet, you can easily identify, okay, you know, this IP is belongs to the class B, class C, or class D. Let me tell you, let me take another example. Over here. So take example, the class A has a range is what? It's a 0 to 126. So if I tell you, okay, the IP is 10.1.10.1, right? Again, this is the 8-bit, this is the 8-bit, this is the 8-bit, this is the 8-bit. This first octet is gonna tell me this is the class A because it comes in this range. Even if I take an example of the what? If I take example of the 124.1.1.1, based on the first octet, he will tell me, hey, this is the class A. But what happened if I'm going to use the 129.172.255.1? I can take the 255, right? Because what's the range of that? 0 to 255. right? That's a range of the IP addresses. So this IP, based on the first octet, I can tell this guy, hey, you know, this is the class B. Take another example. I said, hey, you know, 172.1.16.1. This is the what? Class B. Because still, what is the range of the class B? The range of the class B is 129 to the 191. Right?
Yes.
Same thing. What happened now? If I'm going to define the 189.256.1.3, tell me, is it a correct IP or not, first of all?
Wrong.
It's a wrong
Wrong.
IP. Reason is that we have a,
256.
you cannot go with the 256, right? It's a 255 only. That's a range we have. So this is the wrong one. Take example of the another one. For example, I said the 192.1.1.1.1 class C. I was a 223.1.1.1.1 class C. But if I'm gonna now another thing, all these IPs, right? A, B, and C, all these IP classes, right? From 0 to 223. These IPs you can allocate, right? You can allocate to whom? You can allocate to a PC, a computer, a printer, your refrigerator, your phone, like whatever the things are coming nowadays, right? Everything's on the IoT devices. Everything, router event, switches event, right? Everything. But the class D IP address, right? The class D IP address you cannot allocate to the PC. You cannot allocate to the router. This is particular dedicated for the applications. Some dedicated server, right? Who is sending the traffic to us. Guys, give me a minute. Hello. Hello. Hey, listen, I'll just call you back. Just give me half an hour, okay? Thank you. So application server, but you cannot allocate to the any host. For example, let me tell you. This is the PC. I can say that, hey, you know, this PC has IP address is 1.1.1. Okay, this is the class A. This PC has IP address is 129.1.1.1. Okay, this is the class B. This PC has IP address is what? It's a 192.1.1.1. Okay, that's a class C. Can you see that what's happening? One IP to the one PC, one IP to the one PC, one IP to the one PC. But the class D IP address, which is for the multicasting, right? You cannot define to the PC. Because the class D, as I told you, right? It's one to group, right? One to group. So for the complete group, I can define the one class DIP, that's 226.1.1.1. That's a major difference is there. Unicast IP, 1 to 1. Unicast IP, 1 to 1. Multicast IP is what? 1 to group. But we are not allocating to the PC. We are allocating to the home applications. A Zoom call. Right now we are doing the Zoom call. What I gave you, how do you attend my classes? Based on the Zoom link, right? That Zoom link is a part of the multicast group. When you click on the Zoom link, you attend my session. That's a kind of group that we have. Now, these are the ranges we have seen that. These are the classes of IP address. Now, two important components we have of the IP addresses, right? A very important components. One is known as a network ID, or we can call a network ID portion, host ID, or we can call it the host portion. Name suggests that a very simple way, right? Easily your name is telling. Network means what? A group of PCs, a group of devices, right? Host means what? A dedicated to the host means what? Host means computer, PC, routers, switches, a dedicated to particular networking device. It could be PC, computer, server, printer, router, right? But if I talk about network ID means what? A network ID you cannot allocate to the, right? You cannot allocate to the one particular person. For example, I cannot say that, okay, this is the network ID that I'm allocating to the PC or not the switches, right? You cannot do that. Network ID is representing, okay, these are the one group right now. For example, I say the PC1, PC2, PC3, PC4, PC5. These are the part of the one network. So the network for this guy is what? I say the 1.0.0.0.0. This is the one network. We have a different network over there. Maybe let me take another color. So these are the called as a host, right? This PC1 is called as a host. This PC2 is called as a host. This PC3 is called as a host. This PC4 is called as a host. This PC5 is called as a host. So we have a host IP for this guy. As the 1.1.1.1.1. This is 1.1.1.1.2. This is the 1.1.1.3. This is the 1.1.1.4. This is the 1.1.1.5. This guy again part of the different network right now, because this guy has a different IP address of 2.1.1.1, 2.2.2.2.2.2.2.3, right? And 2.2.2.4. So IP addresses are the two components of very important. That's the network ID and the host ID. But again, the confusion part, you know what? Who is gonna tell how many host and how many network IDs there? Okay, I got it. This is my 1.1.1.1. This is my IP addresses. That's perfect. But who is gonna tell me, hey, how many host person is there and how many network person is there? That's again create a problem, right? So what happened in the, again, when the IP addresses was right founded on that time, we found another guy, and that guy name is a subnet mask. So IP was already there, but right, IP was already there, but we cannot identify how many host portion and how many network portions are there in the IP. So what happened? Subnet comes in the picture. Subnet tell to the IP, hey, don't worry about that. Okay, I will tell you, okay, how many host portion you have and how many network portion you have. And that's how the subnet mask comes in the picture. Every classes, right, has a default subnet mask. Every classes has a default subnet mask. That tells how many host bit and network bit they have. Based on subnet mask, see the importance. Based on subnet mask, we can identify these classes are for big network or small network. So based on the subnet mask, because if you don't know the subnet mask, you cannot understand, okay, this classes are for the big network or a small network, because this subnet mask is going to tell you, okay, these guys have these many hosts, these classes have that number of hosts. So based on the subnet mask, we can identify, okay, can I go for the big network or a small network? So the default subnet mask for the every class is what? If you see right now, yes, that. Yeah. So default subnet mask for the every class is what? So if I talk about the class A, the class A has a default subnet mask is a 255.0.0.0. Class B has a 255.255.0.0. Class C has a 255.255.0.0. Where 255, right? If you see that this 255, as I told you that we have ranges only the 255, this 255, right, is comes in the picture from this value. The value is 2 power 0 is equal to 0, 1, 2 power 1 is equal to 2, 2 power 2 is equal to 4, 2 power 3 is equal to 8, 2 power 4 is equal to what we call 16, 2 power 5 is equal to 32, 2 power 6 is equal to 64, and 2 power 7 is equal to 128. I cannot go 2 to the power 8 over there. The reason is that it will give the value 256. That's why we cannot go that. So right now, the 2 to the power 7, we have a 128. So if you see right now, right, if you're going to add all this value 1, 2, 4, 8, 16, 32, and 64, 128, you will get the 255. So in this one, if I'm gonna explain, not explain, if I'm gonna deep dive for this guy, what I can do that simply, let me put it in the down. Okay. Yeah. So what I can do that, let me write on the binary for this guy, then you will understand in the very deep way. So the binary for the 255 will be what? All the, because we have an 8-bit, right? Remember, we have 8-bit for this guy, we have 8-bit for this guy, we have 8-bit, we have 8-bit. It means 8 values, right? 32 values we have right now, right? So what I told you, if I'm gonna add all these values, right, it will give the 255. So all the values is on right now. So what I can write, I say the 1, 5, 6, 7, 8. Then all my this value is 0. All my values are the 0, 0, 0, 0, 0, 4, 5, 6, 7, 8. Then 4, 5, 6, 7, 8. Then 4, 5, 6, 7, 8. That's 8, right? I think so. 2, 3, 4, 5, 6, 7. Yeah. Same thing. We have a class B now. If you see the class B, right? The class B, if you see, we have a 255.25. These are the default subnet mask, right? I'm not defining. This is not defined by me. It's a default one. Because we have a 2 values. So if I'm going to add the 250, if I'm going to make the 255, we need to add all this value, right? We need to add the 128 plus 64, right? We need to add the 1 plus 32, add 1 plus 16, we need to add 1 plus 8, we need to add 1 plus 4, we need to add 1 plus 2, we need to add 1 plus 1, we need to add. It will get the 255. Same thing you will have for what? Class C. And the class C, we have a these bit are on. Now here in subnet mask, guys, in subnet mask, 1 represent network portion, right? And 0 represent host portion. And this guy. Now you may have a question, hey, Long, what about the class D and class E? Class D and class E don't have a subnet mask. We don't have any subnet mask for the class D and E. I cannot explain you right now why we don't have, because it will take a longer and longer time, and that's not a part of it. So even you cannot understand right now, because multiclass has a different lecture, so leave it. But yeah, we don't have any submit mask for the class E and D. No submit mask. Class D. Now, if you see right now, okay, if you have a look over there, what I point over there, 1 is going to represent the network and 0 is going to represent the host. So if you see in the class A, the 8-bit are the network portion. It means that what I told you about the network, you cannot assign to PC, computer, laptop, printer, router. You cannot assign. Host means what? Can assign to the PC, computer, laptop, router, switch, anything. Even the firewalls too, right? So if you have a look of the class A has a these amount of host portion. Can you see that? 24-bit. We have a 24-bit of the host portion. If I just write down over there, you have over here, it's a network portion and bit. I'll just put the network, right? We have a host over here, 8-bit again host portion, 8-bit again host portion, and 8-bit again host portion. Same thing. Oh, I'm so sorry. Same thing over here. These guys, now we have a 16-bit as a network portion. So it has a big network, but has a lower host. This guy has another big network, but has a lower host. So this one, if you see, I have a big host, 24-bit is a host one. 8-bit, 8-bit, 8-bit. So we have a 24-bit is a host portion. We have only 16-bit as a host portion, and we have only 8-bit as a host portion. So this IP, if you're going to use the class A, the class A is dedicatedly recommendation to use in the big network. I'll tell you what. If you go to the ISP, right? Let's give me an example right now. If you go to the ISP service provider and say that, hey, I need a public IP. Okay. So when you ask to the public IP from the ISP, mostly they will give you from the class A or maybe the class B. Let me tell you, I have a public IP in my home right now for my server. So I'll show you that. So this is not this one, this is the scene. This is the public IP that I'm paying for the money for this one, the 122 range. The 120, based on the 122, you can identify this is the class A. So I have a one dedicated server, that's a 512 gig RAM, right? So I'm using for my personal use. So for that one, so I'm using a public IP so that I can, anywhere in the world, I can remotely access that particular computer, right? Anywhere, right? If the internet is there. So I'm paying for this money. So whenever you ask for the service provider, right, hey, I need a one IP for one IP. So mostly they will give you from the class A. Then the class B is for the medium size network. And the class C is for the small size network. So every IP, right? every IP has a subnet mask information. And based on the subnet mask information, we are identifying how many host person they have and how many network person they have. Right? Guys, feel free to ask me any question from here.
No, sir.
Great.
I have one doubt, sir.
Yeah,
So
go
we
ahead.
can, because we can connect to more number of bases class A, right?
Okay.
That is correct, no, sir?
Modem? No, it's up to your service provider.
No, I'm asking if we are calling it is a big network class A because it have more number of hosts can be connected, like more number of bases or more number of
And that
How-
I'm coming to the point. Just give me 5 minutes more, then you will understand more detail about this. I understand your question. Hold on. Just give me 5 minutes. So now IPs, sort of you're writing something on my screen. So IPs are very important part, right? I told you that the IP is going to represent that the location and identity. It's very important terminology, right? So when you go to the higher level, right? Like, maybe in the data center, right? You will heard even in the data center, even the SD access, that's a higher level CCI enterprise. So you will get the terminology like LISP. So this IP is identifying the location and identity. This is the problem. But Lisp has solved the problem. It is a protocol that you may encounter in the CCI enterprise and SDXS or maybe in the data center. But IP has a very, very important role in the networking, very important role. And the first of all, IPs is at starting when the IP was introduced, right? When the IP was introduced and starting in the 1985 time, IP, it's not free, first of all. It's not free. And even when it was introduced, it was not free on that time as well. You have to pay the money. So to avoid this problem, what IANA said that, because yesterday I told you that IANA, right? This is the one organization that is allocating the number on the networking side. Number could be anything. The IP addresses, right? And the AS number too. So if you guys had experience, then you may heard about the AS number concept, right? So IANA assigned the IP addresses, right? And the AS number too. So you may heard this word AS number in the BGP when I'm going to teach you that.
Yes, sir. Yes, sir. Autonomous system.
Autonomous system number, right? So when the IANA assigned the IP addresses, right? IANA said that, oh, okay, let me do one thing. Let me divide this IP addresses into the 2%. What they did, they said that, okay, because, some companies, they are talking to the internally. It means that, take example, these are the PC. Understand this concept right now, right? And these are the servers. So this is the one company, they are connected with the switch right now. Okay. So they are communicating internally. They don't have any connectivity with the internet right now. They don't have any connectivity with the internet. And some company, right, has a connectivity with the internet. So what IANA did, IANA said, okay, these guys are only communicating internally within the company network, right? They are not communicating beyond the company network. So IANA said that, okay, you guys can use the private IP addresses. You guys, right, this is the one company, they are communicating with the internet side. For them, IANA said that you can use the public IP addresses. So IANA gave you the two flavors of the IP. The first is a private IP addresses and public IP addresses. Initially, IP was only public. Not public, IP was IP. There's no public and private at the starting. IP was IP. But later on, they changed the name, okay, because there was exhausted with the IP addresses, right? People were using the IP addresses, right, for the computers and everything, right? So IANA said, okay, because if we are going to assign the IP address to the every devices, right, and every PCs and the computer wants a unique IP addresses, then the IP would be like, would be exhausted in the next few years. Then INA said, let me do one thing, let me use the private and public concept. So based on this one, private and public concept, right, what we are doing right now, we still have few IP addresses in the IPv4 right now. We are not exhausted now. The private concept and public concept is what? Private IP addresses. And public IP addresses. Private IP addresses, first of all, it's free to use. It means that you don't need to take a permission from the ISP even, right? You don't need to pay any money for this one, right? Public IP addresses, you have to pay the money. Private IP address can be duplicated. The reason can be duplicated because it's free. So maybe take example. This is the one company, right? Company is a XYZ, and there's some users are sitting over there, right? So these guys are using the private IP addresses, right? Maybe these guys can also use the same private IP addresses. So let me tell you the one range of the private IP address. So we have a range is 10.1.1.1. Let me put the over here. So 10.1.1.1.1, 10.1.1.1.2, 10.1.1.3. This is the range of the private IP address. I'll write it over there. Don't worry about that. Same way, the company ABC can also use, right, the same IP because it's free, right? 10.1.1.1.1. So you may face the duplication in the private IP addresses. That's why it is a recommendation. Don't use on the internet side. It's not routable. It means that you cannot use on internet. Because of this, because it's a duplicate, right? Tell me one thing, if I'm gonna understand this concept, if I'm gonna send this information on the internet side, what happened? Internet either can pick the XYZ or either it can pick the ABC. He cannot pick the both IP addresses. Either he can pick the this one, either he can pick the this one, based on the some rules that we'll discuss that rule in the routing part. But he can either pick this one or this one. Or maybe if you do some kind of policy, then he can pick the both one. But in that case, what happened? Your traffic will be misused, right? So the private IP address is not routable. You cannot use on the internet side. Because of this reason, it's a recommendation to use internal purpose. Only internal purpose. So if you're communicating itself, then you can use it. But don't use on the public end. Whereas the public IP addresses, right? It cannot be duplicated. Always unique. It's routable. Understand the concept. So same company. Let me take an example over here. So company XYZ. I have a PC. I have another PCs. I have another PC. So I have IP address is 1.1.1. I have IP address is 1.1.2. I have IP address is 1.1.3. This guy is a different company ABC, right? And these are the PCs. These are the PCs and these are the PCs. This is 2.1.1.1. 2.2.2.2.2 and 2.2.2.3. Can you see that what's happening over there? Let me correct. Let me define it the correct way. 2.1.1.1, 2.1.1.2, 2.1.1.3. Can you see that over there? What's happening? So these guys can route over the internet side. The reason is that it's unique. The public IP address must be unique, right? And you can download on the internet side. Let me tell you, if you see right my RDP, right? Can you see that this is the 122? This is the public IP address that I have. What's the meaning of route table? The meaning of route table, right? You can try even right now, okay, from your laptop, right? From your laptop itself, if you're gonna ping this IP, you can easily send the traffic. Let me check my Wi-Fi is working fine or not, first of all. Whether you can ping it, so that, oh, it's not working. What is 6.161? My Wi-Fi is off right now. Maybe you try to ping your site. Let me check which Wi-Fi I'm connected with. So 5G. So I'll do one thing. Hold on. Let me connect this guy. Okay, for the few minor second, right, there will be drop. Just ignore it. Oh no. Let me pause the. So you can see that I'm able to reach this public IP. Even you can send the traffic to him. So if you're gonna ping from your laptop even, right? If you're gonna ping from your laptop, you can easily send the traffic to this guy. That's the beauty of the public IP. But I have another IP as well for the same server. It means that, you know, my server has a 2 IP addresses. I have a 1 IP address that I have allocated is the, which one is that? It's 6. I think so 1.50 is there. Yeah, it's a law, the 1.50. So I have this IP address, but you cannot ping this IP addresses from your laptop. The reason is that this is my local my network. In my local, this is private IP addresses. I cannot send. So we have a range for this one. The range we have. If I talk about the private IP address range, so for the class A, the range we have is starting from the 10.0.0.0 to the 10.255. So any IP that falls in this range, right? Submit mask, right? That falls in this range is called as the private IP addresses. And that's still not be routable. Class B, we have a range is starting from 172.16.0.0 to the 172.16. Not 16, 31.255.255. The submit mask for this guys are default. Class C, we have a this is the range of the class C. Let me do one thing. So this is the range of the private IP addresses. Even the APIPA, right? Somebody asked a yesterday question, the APIPA, the 169.254, right? This is the range, I think so. The 169.254.255.255. This is the range of APIPA, I think so. Automatic private IP addresses. Automatic private IP addresses, or APIPA. Right? So even this IP address is part of the private, not the public. So these are the major private IP addresses range. So if you are see in your network, right, these range of the IP addresses, then assume that this IP cannot reach to the internet. If condition is there, right? If your PC has IP addresses, take example, this range, the class A 10 dot, which is the private IP address. And if this guy is able to reach the internet side, then 100% there will be a NATing. 100% there will be a NATing. That we'll discuss later on. Don't worry about that. But yeah, you know, many things will becomes in the days by days. Don't worry about that. But I'm telling you, you will be feeling expert level, right? Within a 2 months. So please bear with me, okay? So if your private IP address, if your PC has a private IP address, right, and if it is able to reach to the internet, there must be an adding on there. Maybe the NATing or maybe something else, right? Now, if you see my RDP one, right? Can you not this one? Let me see my command prompt, right? Can you see that? This command prompt that I reached. Come on. Yeah, you can see that. This IP, right, is not belonging to this range. This IP is not belonging to this range. So if it is not belonging to this range, it means that this is my public IP. That's all for the today, man. I'm done for the today. Let me know if you guys have any questions. Okay. We are not done. We have lots of things. You can feel free to ask the question.
Yes, sir. I have a question.
Yeah, Vijay, go ahead.
Yeah, as you showed us, your server has a public IP of class A, right?
Right, so
But the public, I mean the private IP was C class range. How can that be?
what do you mean a C class range? Oh, you were saying
Your,
that you were saying that my server that
yeah,
I
your server. Yes.
okay, I understood. So what I did, okay, so the public IP that I got from my ISP, okay,
Mm-hmm.
that's a range of what is it? Let me take the range. It's a 122.166.46.161, right? This is the IP, right? That I took it.
Yes.
So this IP that ISP gave me, okay,
Yes.
okay, private IP,
Mm-hmm.
you know, that I allocated from my end only. So I can allocate the class A as well. I can allocate the class B and class C. So I have allocated the class C.
So you can allocate any
Yeah,
private.
yeah, I can allocate any can. So, you
Okay.
know, what I can, what I can tell you, 1 minute, hold up, let me check. So this guy, can I show you right now to how to allocate? Okay, I think so. That's EXXI server is there, right? So I cannot show you, but yeah, I have allocated myself this one. So I can change the tomorrow as well. If I want, I can change the 151 as well. So I think so 10 days back, I have changed there's some attack was happened on my server. So something I make changes over there in my server side. So I can change it. So maybe if I want, I can make a 10 submit as well. If I'm
Okay. So, yeah, I understand now. So it doesn't have any problem
it doesn't have any
accessing the
problem.
internet, right?
No, there is no problem, man. But
Oh.
make sure that when you took the public IP from the ISP side, right, your mapping should be correct. Your mapping should be correct. The reason I tell you that, so if you see right now, I have a 2 Wi-Fi connection at my home right now. One, this Wi-Fi connection that I'm using right now, that's my, my every purpose, right? My TVs, my office works and everything, right? So right now I'm connecting with this one and I can ping the public IP. Can you see that? I can ping it. There's no issue. But what happens if I'm going to change my Wi-Fi? Okay, zero touch. That's I dedicated for the server. So if I'm going to make this guy changes, now I cannot send the traffic. The reason I'll tell you. Drop. The reason behind it, someone did the wrong mapping on my server right now. So I haven't resolved the issue. So 20 days back, there was an attack happening on my server side. Then after that, I was trying something like, to remove those things because someone has deleted my all the EXXI and everything, right? And then I reinstall it and reimage everything. And somehow I click on something settings, right? And after that, this mapping has gone. So I need to change the mapping. Then the IP will be pingable from this Wi-Fi. That's a problem. So your mapping should be built correct.
Well, I have another question.
Yeah.
About
Hi, sir.
Yeah. 1 minute. Let me complete the buzzer. Vijay.
Okay. Layer 3 switch. Does layer
Okay.
3 switch serve as a router too.
Yeah, a layer 3 switch. We haven't discussed, Vijay, we'll discuss this thing as well. Yes,
Yeah, I
it
just
can
wanted
do
to.
that. It can do that. Aaron.
Okay. Okay, thank you.
By default, this feature is disabled. You need to first enable it.
Okay, thank you very much.
Most welcome. Yeah, Vijay, you go on.
So one question from my side.
Yeah.
Sir, how we are using proxy?
Yeah, you're asking the proxy something?
Yes, yes.
So you are suggesting me to use proxy on my server, or you are asking the proxy? If you're asking, then we'll discuss the proxy.
Why? Yes.
So you're asking, right? So we have a proxy concept in coming lecture. Don't worry, we'll discuss that.
Okay, okay. Thank you, sir.
Thank you. So I'll tell you, we have lots of things, man. We are like, I'm telling you, we are discussing very basic part. We have a very detailed discussion over each and everything. We'll see the debug level. I'll show you how to do the debugging, how to do the Wireshark capturing, everything. So you can see that right now, right? So,
Yes, sir.
I'll
Yes, sir.
explain you like, how to check the each and every bits over there, right? What is the use of each bits, right? Or what is the exception of this query packet? What is the use of this guy as well, right? So don't worry about that. We are gonna discuss each and everything. Okay.
Hello, sir.
Yeah.
Sir, I have two question. In a network, what is traffic? Network traffic?
I didn't understand your question. Your question regarding the control plane traffic or data plane traffic regarding that way?
No. I am just asking, sir, what is network traffic?
Network traffic is a normal traffic is called as a network traffic. Your control plane traffic is also known as a network traffic.
Okay, sir.
We'll discuss. I'll let you know
Uh,
the control plane and data plane.
Actually, sir, I am traveling now. My network issue. Tomorrow I will ask sir details, sir. I am traveling right now.
Pakka. Definitely. Don't worry.
hello, sir.
Yes.
Sir, can you have discussed how to design the network topology and
Network
etc.?
designing, right?
Yes,
Okay.
sir.
So do you know one thing? Okay, let me pause the recording. Otherwise, the recording will be increased and somebody will be bored during the watching this thing, right? So let me pause it.